Alt-R. Did it work? Oh, I think it's working. All right. So today, we are going to add a few more properties of equality and properties of congruence to our sheet. I'll have a sheet printed out for you guys tomorrow. But we've got a couple more we get to talk about. So remember, we still have all these guys: addition, subtraction, multiplication, division, distributive, substitution, reflexive, symmetric, and transitive. Then we have our congruence: reflexive, symmetric, and transitive. What were the two other ones we learned yesterday? There were dos más, por favor. Segment addition postulate and midpoint. So angles, those are some pretty special characters. There's a lot of stuff that can happen to an angle. Definition of congruent, we know that one. If it's equal, it's automatically congruent, and if it's congruent, it's automatically equal because it's what kind of statement? Biconditional. Definition of a right angle. An angle is a right angle if and only if what? It's 90 degrees. What kind of statement is that when it says if and only if? Biconditional. So definition of congruence, definition of right angle. Let's see. Definition of complementary angles. Two angles are complementary if and only if their measurement is 90 degrees. What's if and only if again? Biconditional. Do we notice a pattern with our definitions? Our definitions are all biconditional, which means they can work either direction we need them to. Definition of supplementary angles. Two angles are complementary if and only if the sum of their measures is 180. If it's supplementary, the measures have to be 180. If the measures are 180, they have to be supplementary, biconditional. Angle bisector. Bisect means to cut in half. So for segment, what words cut in half? Yesterday. Midpoint, great answer. So bisector, cut in half. And when I say cut in half, what do I mean? Huh? When I say cut in half, if the angle was 80 and somebody bisected it, what would each individual angle make? If the big angle is 80, cut in half, each angle would be 40. Angle bisector. One more time. What's that? If it was 180, it'd be 90, yeah. Definition of perpendicular. Perpendicular lines form right angles. And if it's a right angle, it measures what? 90 degrees. Angle addition postulate. We saw those second two words yesterday. What was the segment addition postulate? Two smaller segments added together make a bigger segment. So when I tell you angle addition postulate, what do you think? Two smaller angles added together come together to make a bigger angle. Vertical angles, we know that. If two angles are vertical, then they are congruent. Complement theorem. Two angles form a right angle, they're complementary. Why does that make sense? What's it mean to be complementary? 180. That's supplementary. What's it mean to be complementary? Makes 90. So if two angles add together to form a right angle, what's a right angle always measure? 90. So if two angles make 90, it has to be what? Complementary. Linear pair, we know this one. Two angles on the same line. Cut by somebody, they are supplementary. What's it mean to be supplementary? Their sum is 180. Good. Congruent complements, I can promise you won't see this one too often. But it's okay. If two angles complementary to the same angle, they are congruent. Did you take a picture of me, son? Yeah. Weirdo. All right, and then congruent supplements. If two angles are supplementary to the same angle, then they are congruent. You guys won't see those last two very often, but we got to talk about them. Sir? No, not that much. And if they do, you'll have it. Another rousing game of name that theory. Woo! Awesome. All right. So we're going to justify each statement using something from Monday, something from Tuesday, or something from today. Y'all look super excited this morning. If C is a right angle, the measure of C must be 90 degrees. Okay, what is the complement there? Two angles come together to make 90 degrees. What do they say about this one? C is the right angle, so it must be what? So if it says it's just the right angle, if I can use the word it's just that, then what are we going to go with? What makes something a right angle? How do we know that? The definition of a right angle. Definition of a right angle.
Wait, so when do you know to use complement here if it's two angles adding up?
Absolutely. If it's two angles coming together to form 90, it's probably complement. But if we're just talking about one angle and they're telling me that rascal's a right angle, I know it's 90 degrees. Speaking of congruent supplements, if X is supplementary to Y and X is supplementary to Z, then Y is congruent to Z. So you're like, what on earth are they saying? So if I've got a straight line, maybe, okay, so we got our straight line here, and then we've got an angle. Okay, so if this is X, and we've got Y and Z, right? Can y'all can't see that? I'm sorry. It looks bigger on my screen. So if this is a straight line, and I've got X, what kind of relationship does X and Y form? A linear pair, which is what? Supplementary, right? So, and then X and Z also forms a what? They also linear line, right? They both are supplementary to X. So because they are both supplementary to X, I can say those two are equal to one another. And we're going to go congruent supplements. Congruent supplements.
Is this one of the rare ones?
And you might not even use that to get, you might use the linear pair theorem twice and then go with, well, because they're equal, I can just use transitive property. Yeah, you won't see it very often because there's a lot of ways to work around it. But it is a shortcut if we can recognize it. If angle 1 and angle 2 are created by two intersecting lines, one is congruent to 2. How do I know that? Why? Why vertical angles? Yeah, so when I see my X, I know opposite angles are always what? Congruent. So there's my X. Those two are going to make my congruent angles, or they're vertical angles. Always, always, always. P plus Q equals 90. Then P and Q are complementary. Ethan?
Yeah, it's
It is the one you were talking about. Which one were you talking about? Definition of complementary angles. Yep. Absolutely. Two angles added up to be 90, then they must be complementary. M and N form a right angle, then M and N are complementary. That's the complement theorem. So when you guys are doing your homework tonight, I want you to think of these pages right here as almost a cheat sheet, because in the proof, there's so much, and you guys are like, oh my gosh, there's so much happening. Like, what is really? But if I come back to this page, these are just lines of a proof. They just got them separated out, and we can individually address them. So these are all could be possible lines of a proof that we can use to our advantage. If L is perpendicular to M, then angle 1 is a right angle. How do we know angle 1 is a right angle? What's that? So what, because L is perpendicular to M, 1 becomes a right angle. What tells us that? Nope, complements when two angles come together to form 90. What do perpendicular lines do, guys? They form right angles. So when something is what it is, what do we call it? A definition of, not a right angle, because right angles would be, if it's a right angle, it's 90. How do we know this is a right angle? Right, but there's a reason it says that. How do we know that angle 1 is a right angle by M and L being perpendicular? Perpendicular lines make 90 degrees. So what would my justification be here? Of what? Complementary angles are two angles that come together to form 90 degrees. This is one angle being formed. Definition of right angle is when an angle is right, it is 90. How do we know this is a right angle? Perpendicular lines form right angles. So we know this is a right angle because it is a perpendicular line. Most likely, yeah. Yeah, it's a good clue. W and X are supplementary, then the measure of W plus the measure of X equals 180. What allows us to say that? How do we know that two angles added together make 180 because they're supplementary? It's a definition of supplementary. L is complementary to M and N. L is complementary to M, and N is complementary to M. Then L is congruent to N. So that's our congruent complements again, but it's not supplements, this time congruent complements. Again, I think there's better ways we can show that. A and B form a linear pair. A and B are supplementary. A and B form a linear pair, then A and B are supplementary. Linear pair theorem, why? Absolutely, if it forms a linear pair, they're automatically supplementary. If N and P are complementary, then the measure of N plus the measure of P equals 90. What do you think? If complementary means 90, two angles, Definition of complementary. Say it with your chest back there. Be confident. Who cares if you're wrong? The test do? So why not be wrong today instead of wrong on Tuesday? Given our diagram to the right, the measure of JKM. So we've got start at J, go to K, go to M. The measure of JKM plus the measure of MKL. Start at M, go to K, go to L. Makes angle JKL. What do we call it when two smaller angles add together to make a bigger one? Angle addition postulate. Come on, stay in there. What are you doing? Angle addition postulate. Oh, Peter. All right, and last one. If the measure of R equals measure of S, then angle R is congruent to angle S. Definition of congruence. So our reasons bank, it grew a little bit. All right? Y'all like, nah, it's pretty bad, coach. It's a lot. The good thing is, I won't make you memorize them all. What's that? You don't have to memorize them. I mean, you got to recognize them, but you ain't got to memorize them. All right, here we go again. Let's do some proofs. Yay. All right, PQR is a right angle. PQS and SQR are complementary. So we're going to mark up our right angle. So let's go to our figure and mark up our right angle. Is there anything we can assume about that angle being a right angle? Can we assume QS split that perfectly in half? No. So that's all we can really do with that diagram right now. So PQR is a right angle. It's given. Half the battle is getting started. So if I said PQR is a right angle, and then they said the measure of PQR is 90, how do they know that? Yes. Definition of a right angle. You guys are going to find out that these angles use a lot of definitions, which takes a lot of the thinking off y'all's plate. So definition of a right angle. Okay, so they went to that. Now they said PQS plus SQR equals PQR. So PQS, start at P, go to Q, go to S. SQR, start at S, go to Q, go to R. Those two equal the larger angle. What do we call it when two smaller angles create a larger angle? Not yet. Angle addition postulate.
That would be perfect, like the wording of the theorem or whatever.
What do you mean?
Like if I put, I addition angle postulate, will you take on point for?
I mean, it's multiple choice.
Right.
It's because I'm evil. How do we know? What did they show? What happened from 3 to 4? Who changed? What's different? So PQR. Was it transitive or substitution? Why substitution? It replaced it. It took its place. Absolutely. I can't write highlighter, dummy. And then what steps? Step 2 and step 3. It'll help you organize your thoughts, but the test is multiple choice.
Right.
PQS and SQR are complementary. Why is it true, though? Definitely not false.
They equal 90 degrees.
Why? So what does that mean?
That's the right angle.
Definition of complementary angles. If you're saying that's because it is, let's see if there's a definition that can back you up.
Wait, so if that's complementary in the description, is complementary angles?
Pretty strong chance, brother. Pretty strong chance that if it's talking about a definition, we fixing to use a definition. Yeah. Word. Number 2. It's okay, I'm weird. Angle 2 is congruent to angle 3. Angle 1 and angle 2 form a linear pair. So when we say something's congruent, we use a hoop. So we know 2 is the same measure as 3. So when we say 2 things are congruent, we use a hoop. And then 1 and 2 form a linear pair. There's not really a whole lot we can do with that yet. So angle 2 is congruent to angle 3. How do we know that? It's given. The measure of 2 equals the measure of 3. What do you think?
Linear.
Why linear? 2 and 3? But they got to share. Yes, they've got to share a split. So what happened from 1 to 2? What changed? They're no longer what? They're no longer congruent. They're now what? They're equal. What allows us to bounce back and forth between equal and congruent? Definition of congruence. I know what you said, son. We just had to get everybody else in there. 1 and 2 form a linear pair. Given. Because 1 and 2 are a linear pair, 1 and 2 are supplementary. How do we know that? Yeah, but yes, but what definition of supplementary? What specifically makes this supplementary? Because remember, we had same side interior that were supplementary. What makes this particular 2 angles supplementary? Linear pair.
Wait, but can't you only have a linear pair to be able to be supplementary?
No. Remember, the same side interior angles are supplementary. So 2 angles add up to be 180 is what makes them supplementary. And there can be multiple ways. Measure of 1 and 2 is 180. So let's use our clue and go back to 4. What'd they say in 4? That they're supplementary, which is 180. So what'd they say in 5? Okay, so if they said in 4 they're supplementary, and in 5 they showed that relationship, what are we going with? Definition of supplementary. Do y'all like these better than the other ones or no? Not as much? It's probably just that you're like not as freaked out. Yesterday there was a lot of letters being thrown at you.
I think it's easier because it has other words and definitions.
Okay. I like it. 1 and 3 equals 180. Where did what they change from 5 to 6? The 2 became a what? What do we call it when somebody replaces another? Substitution. They substituted that. What is 5? They combined 2 and 5. So this rascal became that rascal. And the last one. 1 and 3 are supplementary. Definition of supplementary. Not given. It's that statement. So we've got to be able to prove it. Yeah. I've zipped out of a helicopter. Pretty cool.
Oh, like in the military where all the Marines is like,
Yeah, like Call of Duty when they show Warzone, there's a zip line out. I've done that.
pretty safe.
Good.
Have you been skydiving?
No, I wanted to, but they wouldn't let me. They told me I was too big to be an air medic. All right, number 3. 1 and 2 form a right angle. 1 plus 3 equals 90. Prove 2 is congruent to 3. How do we know 1 and 2 form a right angle? So let's go ahead and mark that in our figure. So 1 and 2 form a right angle. Remember, we signify a right angle with that box. One and 2 are complementary. How do we know? What's that? Yep. Complement theorem. What does the complement theorem tell us? If 2 angles are right angles, then they're what? Yeah. So you're right, dude. Most of the words are going to be right there when we need them. How do we know 1 plus 3 equals 90? They gave it to me. So how do we know 1 and 3 are complementary? Yeah, complementary angles. Yeah, definition of complementary angles. I'd say 2 and 4 are pretty much the same. All right, and lastly, how can we say 2 is congruent to 3? This is that one you won't see very often. So because 1 and 2 are complementary, and 1 and 3 are complementary, 2 must be congruent to 3 based on which one? Congruent complements. Yep. Boom. Let's keep this train a rolling. Plenty of time. Oh, there's that fun word. Bisect, what's it mean? Bisect, what's it mean? Yeah. So it forms what? If it cuts something perfectly in half, the two angles are going to be congruent. Good word. The measures are equal. The angles are congruent. So BE is bisecting ABD. So that's one hoop here, another hoop there. And BD bisects EBC. Now, do we know that those two are congruent yet? The blue, the single hoop. So we don't know yet, so we're going to go double hoop. Okay, so that's how we just show varying forms of congruence. If there's multiple angles, we just go up a hoop. Just like when we went up tick marks in transformations each time it happened. If we want to show multiple things are congruent, we're just going to go one hoop for the first one, two hoops, then three hoops. And if we want to show tick marks on our congruent sides, same thing. We just increase the number of tick marks. All right, how do we know BE bisects angle ABD? They told us. Thank you very much. So because we know it bisects, what tells us that ABE is congruent to EBD? Why does it cut it in half? No, so that would be equal to congruent. The bisector. So because it's a bisector, it cuts it in half. Definition of a bisector. Absolutely. On fuego, senor. Definition of an angle bisector. Spell bisector right, dummy. If somebody ever comes across these videos and just listens to me talk to myself, they're going to think I'm loco. They're like, why is this guy insulting a child and not writing highlighter? How do I know BD bisects EBC? They told me. They didn't tell me. I wouldn't know. How do I know those two angles become congruent? Definition of? Not congruency. Definition of, what they say in the step before? The given, right? So they told me that it bisects. So when I see something bisects, I automatically know it does what to that angle? Cuts it in half. And what tells me that it cuts it in half? Definition of a daggone bisector, I tell you what. All right, and lastly, oh, Peter, ABE is congruent to DBC. So let's get our highlighters out. Let's see if we can't find where we've seen that before. Where did we see an ABE? On 2. Let's switch our colors. Where did we see a DBC? 4. Do we notice anything in particular about 2 and 4? They're both congruent to who? EBD. So because they're both congruent to EBD, we can drop EBD and say they're congruent to each other. What property allows us to do that? Transitive. Good. Why not substitution? So it's because they both, so we've showed that they both equal, or I'm sorry, they're both congruent to EBD, right? So because they're both congruent to EBD, they must be congruent to one another. Again, substitution isn't necessarily wrong, because if you said EBD was substituted for ABE, you're not wrong. The more right answer is transitive. I'd probably give you full credit for it, honestly. But I'm going to show you the most right way. You're not wrong. That's what I told y'all yesterday. Like, it can go back and forth. Was it yesterday? Yeah. You just talk, and I just kind of stare at you blankly. What steps? Two and step 4. Let's do one more. We got time for one more. And boy, oh boy, is she a doozy. Look at that 7-step, beautiful piece of mathematic art. They told me RSU is congruent to BST. So how do I label that in my diagram? With a what? RSU is congruent to TSV. Give it a hoop. And a hoop? No. All right. I know. He's a weirdo. It's fine. So how do we know that piece of information? They told me, so it's given. Next step, what'd they change? They changed it from congruent to an equal sign, so we call that definition of congruence. Yeah. RSU, oh, Peter, come on now. RSU, so we start at R, go to S, go to U, RSU plus USB, so USB, make angle RSV. What do we call it when two smaller angles come together to form a larger angle? What? Angle addition? Anytime two smaller things come together, you're going to have some kind of addition postulate. What about, I need to switch colors, some purple. VST, so V to S to T. And, oh, it's a terrible color, but we'll use it. USV, what a just awful color. Makes UST. What's that?
No, wouldn't that also be angle addition postulate?
It would also be angle addition postulate. Oh, Peter. It would also be the angle addition postulate. Two smaller angles come together to form a larger one. RSU plus USV equals UST. What changed from 4 to 5?
Wait, you would substitute, right?
Why substitute?
Number 2 and 3.
Not 3.
4.
Yeah, 2 and 4. We're substituting. Look at you guys. What's that? Step 2 and step 4. So who got substituted? RSU was replaced by VST because of step 4. Man, look at y'all. That's awesome. RSV equals UST. What is that? Did they drop one? What do you think? Who did they drop? So where did they get RSV from? Find our there. I like that we're getting after it now. So RSV, where, oh, can't write in dummy. RSV, where else do we see RSV? 3, where at? The equal. Okay, UST, where else do we see that? On 4 and 5, right? So what's different between 3, 4, and 5? What do we see another commonality? Do we see something else that's in common? Look at this term right here versus that term. What do we know is true about the yellow highlighted RSV and the blue highlighted UST? They're both equal to what? Do they both equal the same thing in 3 and 5? They do. So if we say that they both equal the same thing, what must be true? If they both equal the same thing, they must both equal each other. What do we call that property? If A equals B and B equals C, then A equals C. What do we call that? We've used it. Come on, ride the train. Hoo-hoo. Come on. Transitive. I know what y'all have been saying, but we gotta shows it. So we just dropped off the RSU plus USV. It was a trap. Yeah, it's a little bit of a trap. All right, and then how do I know angle RSV is congruent to angle UST? Definition of congruence. All right, let's take a peek at your homework. See how much I want to give you out of that. 50 problems? What do you think? 50? 50 is okay? Divide by 50. Ooh.